Drought is not a new phenomenon in the Philippines. In fact, according to Pag-asa, during the last half-century, there have been 12 weak, moderate, and strong El Niño events which are associated with drought that have brought adverse socio-economic impacts to the Philippines. Whenever there is drought, the problem will always be carried down to the agriculture sector. This study involves using sodium polyacrylate, an agent that can hold huge amounts of water and is found in disposable diapers, as an additive to soil to improve its water holding capacity. The researcher chose this topic in the hopes of finding out ways to help Filipino farmers with their problems in irrigation. This project would be a great contribution to the community, specifically to the following. Number 1. Household gardeners. People may withdraw from keeping plants in the household due to the time and effort needed for their maintenance. As this study will help to find a way to improve the capacity of soil to retain water, it will therefore provide people a method that would require them less effort in terms of watering their plants. Number 2. Farmers. This study will also be helpful to farmers whose hearts are always burdened by problems with water and irrigation, especially when drought arises. Number 3. The academic community. Lastly, the academic community will also benefit from this study, as it is for the contribution of knowledge that this project has been brought forth. The study intends to investigate on the feasibility of sodium polyacrylate present in disposable diapers as an effective agent of soil water retention improvement. Moreover, the study seeks to answer the questions that follow. Number 1. Does sodium polyacrylate improve soil water retention? Number 2. What are the effects of sodium polyacrylate on plants? On the growth rate of plants over a period of time? How about on the time it takes before the plant withers? Number 3. How do the different setups compare to each other? Which is the most effective in keeping the plants alive? Since one of the objectives of this investigatory project is practical application, the researcher made sure that the procedures are easy and economical. The materials and equipment used can be found in the household, making the project accessible to anyone. The process for the general procedure is as follows. Number 1. Wet the disposable diaper and rip the covering off. Number 2. Dump the wet contents of the disposable diaper into a bowl. Number 3. Add more water into the bowl and mix until the consistency becomes gel-like. This is now what we call the hydrogel. Number 4. Once the hydrogel has settled, mix it with equal parts soil in another bowl. Mix further to make even. Number 5. Once the components have been equally mixed, dump them into a container where you wish to place your experimental plant. Take note that procedure numbers 4 and 5 may vary according to what is required by the control and variable groups. These control and variable groups are to be discussed later on. Number 6. Plant the seeds just on top of the soil. There should be 5 seeds per container. Number 7. Water the plants for the first and the last time except for control B, which should be watered daily. The amount of water poured in one container should be the same for all. In the experiment, the researcher used 15 ml of water in all setups. The control and variable groups refer to different methods of application of hydrogel on soil. Through the observation of these groups, the researcher would know which setup is best in keeping plants alive. The setups of these groups are as follows. In Control A, no hydrogel was mixed with the soil. This group is watered only once at the beginning of the experiment. There is also no hydrogel mixed with soil in Control B. However, unlike Control A, This group is watered regularly throughout the experiment. In variable A, application of hydrogel is only at the surface of the soil. In variable B, application of hydrogel is in the middle. In variable C, application of hydrogel is at the bottom of the container. And lastly, in variable D, hydrogel is mixed with the soil all throughout. Variables A, B, C, and D are only watered once at the beginning of the experiment. The researcher measured the tallest growing plant in each setup from the surface of the soil to the tip of the leaves of the plants. The observer took the measurements daily for 10 days. After the observation period, the researcher was able to infer the following. Number 1. The plant in control B has shown to grow the tallest, while the plant in variable A has shown to grow the smallest. Number 2. When it comes to duration of life, data shows that variable C, wherein the hydrogel was placed at the bottom of the container, sustained plant life the longest, while variable D, wherein the hydrogel was mixed with the soil, sustained plant life the shortest. This is if control B will be disregarded, since it is obvious that it will sustain plant life the longest among all setups since this group is watered on a daily basis. Based on the results of the experiments and observation, the researcher comes to the following conclusions. To some extent, sodium polyacrylate does improve soil water retention. When the variable groups, which are those with sodium polyacrylate in them, are compared to control A, which is the setup without the sodium polyacrylate, the plants in the variable groups surely did last longer than those of control A, even though both setups were watered only once in the beginning of the experiment. The effects of sodium polyacrylate on the growth rate of the plants cannot be empirically determined by the researcher when data at hand is the only data to be used. Although moisture supply may have influenced the growth rate of the plants, there may have been an array of other factors that have also contributed to the growth rate of the said plants. These factors include environmental factors such as temperature, composition of the atmosphere, amount of solar energy, and supply of mineral nutrients in the soil, and genetic factors, or those embedded in the plant's genetic composition. These factors are outside of the study and therefore should not be emphasized nor neglected, as there is a huge possibility that the inconsistency of the heights of the plants was a result of these varying circumstances. Although the researcher cannot accurately measure the effects of sodium polyacrylate on the tallness of the plants, data collected is sufficient in order to infer the effects of the substance on the longevity of the lives of the plants. As it is shown in the results of the experiment, sodium polyacrylate did have a significant effect in sustaining the plant life. Variable groups containing hydrogel are shown to sustain plant life longer than that of control A, a setup without hydrogel. Based on the results gathered, the most effective hydrogel application method is that of variable C, wherein the hydrogel was placed at the bottommost part of the container beneath the soil. The explanation behind this is simple. The surface of the soil is where the water particles interact with the surroundings. This is where radiant energy from the sun may turn water into vapor. By placing the hydrogel at the bottommost part of the container, it is as far away from the surface as possible, therefore saving the water particles in it from being vaporized. Thank you for listening. Until next time.